I want you to guess which element I'm talking about. And we're assuming that this is the last electron in. I'd have to tell you that. I'd have to tell you which electron I know which electron it is, okay? In. We know, this tells us it's the 2p. And don't forget, I said you've got 6. I had to think about this one. That's -1, that's 0, that's +1. That would be -1, 0, and +1. So this would be +1/2 for these, and these would be -1/2. Ah, right? Because these are the second ones in, and by convention, we say the first one in are spinning up. Six. Yeah, totally makes sense now, right? 3 orbitals, 2 electrons each. Okay, does that help? So Dan, it is boron. You want another one? Yeah. Okay. I'll stick to either the S or the P, okay, to make it easy. So that one was boron, this one's magnesium. So if you have an S orbital, there's only one orbital of that type on that energy level, because there is one value for ml. Okay. If you have a p orbital, there are 3 possible p orbitals on that energy level. You okay with that?
What does it mean by actual?
There's 3 separate p orbitals. You've got a px, you've got a py, and you've got, really hard to draw, a pz. So what this is saying is they are orientated along different axes in space. One is along the x-axis, one is along the y, one is along the z. So there's 3 discrete orbitals when we're talking p's. Yep.
How do you know which one's on X, Y, and Z?
You're not going to worry about that. Okay? Now, all the p orbitals on a specific energy level are degenerate, meaning they are equal in energy. Remember when we were looking at the house, the S and the P for the same energy level were not on the same level? S was lower than the P. They are not degenerate. That's why we're talking about subshells. There's 2 different energy levels. So if you have energy levels, or orbitals, rather, orbitals that have the same energy, they are called degenerate. So we're talking about all the p's on the 2p level are degenerate. All the p's on the third energy level are degenerate. All the d orbitals on the third energy level are degenerate. So they have the same energy. Your principal quantum number, n, also tells you the types of orbitals on that energy level. So I know that if I'm on the second energy level, I have two types of orbitals. I have s and I have p. If I'm on the first energy level, I have one type of orbital, just the s. When we got to how many actual orbitals there are on the energy level, we said it was n squared. So the second energy level squared is 4, and this is the 4. We've got one s orbital and 3 p orbitals for a total of 4. So it's not just these aren't random facts, they're connected. N squared works because if you add up the ml values, the number of ml values, that is for each specific orbital. Yeah.
So for the thing that we were drawing earlier, like this, can you see that? You know the little boxes?
Yeah.
That's what it's supposed to look like, right?
So that's sort of an energy level diagram.
Is each little box here one orbital?
Yes.
Okay.
Okay. But again, being as efficient as I am and not lazy, when I do energy level diagrams, I put lines instead of the box. I just draw the bottom line. But that's what that represents. Each box represents an orbital.
How do you know if it's full, that third box? Because you're saying it's 3p. How do you know that third box is 1 electron or 2? You know what I'm saying? Like you said it's 1s3p, right? That's the configuration for that?
So we've got one s orbital and 3 p orbitals.
Right, and there's 2 electrons in each.
You can have up to 2 in each.
So for the third p,
Yep.
how do you know if there's 2 electrons in that third orbital?
It depends on the element
Okay.
or the ion. Yeah, totally. Yep.
So ms would be n to 3 then, or do we say
No.
that?
It's either plus a half or minus a half.
No, I mean like the little n.
Sorry?
If you put the n squared on the side,
Yeah.
it's n to 3 then? Is there 8 options?
No, it's
No.
yeah, it's just the end.
No.
Oh, okay.
Like, what math are you doing? Is this new math they're teaching you? Am I really behind in my... If n equals 3, what are the values for L?
0, 1, or 2.
What are the values for ML if L is 0?
0.
For 1?
-1, 0, and 1. And then -2, -1, 0, 1, and 2.
Devanchi, there's other people in this.
With their hands up.
Okay, so there are 3 types of orbitals on this energy level, right? N is 3. We've got an s orbital, we've got p orbitals, and we've got d orbitals. There's our 3 types. How many actual orbitals should we have? 10 or 9? Okay, I see your thumb's not there now. And look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 actual orbitals. There they are.
So what would the configuration be again?
N squared gives you actual number of orbitals.
Sorry, I meant S and P. What would that the configuration, like 1s3p, that's what you're saying? That's the configuration. Don't you not figure something like the very end? Like an S and P? The last one is just S and P.
Wait, so it goes down?
Wait. Somebody is ahead of you. I was asked, well, what does this mean?
Isn't that like the maximum electrons?
That I can fit on that energy level, right? Because if n squared gives me these values here, and for each one of those can fit 2 electrons, on this energy level, I should be able to fit maximum 18 electrons.
Miss WP, that's
Nope.
what I meant when I said n to the 3.
Oh. Is this not allowed? This is actually one of your homework questions last night.
They have their time.
Oh, that's not possible because L has to be 0.
Yes, if n is 1, L cannot be 1. It has to be 1 less. That's why there's no 1p.
Rotated this picture right here, we're at another level.
So, in order for L, you know, I get that it looks like the way I think about it.
If we were at another level to this, this would be 4x right here, right? And this would be 1d. Why is there no? Oh, it has to be 3. And then what's the next one after that? 4 after that. I don't see any of them.
You know, I remember it.
That's how I remember.
Went to the
Oh, it's
report.
3. Because you're going to take you're here.
Really complicated.
You just do it in someone's way. Like, for breaks and all this stuff.
I'm being honest.
All right.
4s, and then it goes to 3d.
Why is there no 2D? Why is there no 2D? Exactly. Josh?
I didn't get the other.
Okay, why is there no 2D? Miss Barnes?
Because n would be 2, and then L would have to be either 0 or 1.
Yeah.
And then the n subscript L would have to be like -2 would be the lowest it could be, and then +2 would be the highest it could be, and D doesn't.
Yeah. D is L equals 2. It breaks the rule that that your L value can only go up to n minus 1. Right? Okay. First sheet of paper. I've just given you a diagram of, these are the basic shapes of the orbitals. So basically they get these by running massive mathematical equations, and these are given by the probability of where you find them. So basically the edge is basically defined by the least probability. So your s orbitals are spherical. As you get to a higher energy level, the orbitals get bigger. So the electrons will be found further out from the nucleus, kind of like our not really true orbits, right? The 3s, the third energy level, was further out from the nucleus. These are your p's. Again, as you go higher energy, the p orbitals will also increase in size. And then there's your d's. Okay, on the back. Basically, they're showing the orbitals filled with electrons. In the first one, they're getting denser because they're getting more electrons in their orbitals. Of course, to a maximum of 2. And then the bottom diagram is really how our periodic table fits together. Right? You can't fit that on a good piece of paper, so we take the lanthanides and actinides out and we stick them on the bottom. So the F block is underneath. This is in order that the orbitals fill. All right. Now, what we're going to be doing after we do today's work, so either tonight or tomorrow, we're going to be talking about energy level diagrams. And I'm giving you this so you can see. The lowest possible orbital that you can have is the 1s. Next highest, 2s. Higher than that, 2p. Then the 3s and then the 3p. And if you look, the fourth energy here, 4s, 4p, 3d. You can see that the 3d is slightly lower than the 4p. So what they've done is they dropped the d down on the periodic table so that you use your periodic table to help you fill in your orbitals. So you will fill 4s before you fill 3d, and then you fill 3d before you fill 4p.
Okay, so like if everything that we were like taught in like grade 9 and 10 was like garbage.
It's not garbage. It's just, it's not a lie. It's simplified. You need to know the concept of positives and negatives, and that this nucleus is positive and then the outside of the nucleus is negative, right? And you need to know that electrons are what is involved in bonding. So it's not a complete lie, we're just getting more sophisticated.
So it is a lie.
No,
It's not a complete lie.
it's not a complete lie. It's not. So this is what I mean. I'm gonna say a few things. Remember last year when I said, well, now I'm changing the story. Okay? Last year, there were times where I said, oh, we're going to get into this in grade 12, like Lewis structures. It's not more lies, it's more complicated. But I'm going to give you tools to help you. Okay. So, any more questions? Yep.
Well, you know when we did the houses, we had like some cases where it was like 1 electron?
Yeah.
And then, so like how would you draw a circle like that?
We're not going to draw circles. When we do it, okay, when we do energy level diagrams, and you'll know this when you watch the video. Let's say I'm going to draw the energy level diagram for lithium. Lowest orbital is 1s. I will also need my 2s. It's higher. I don't have to put relative amounts on my paper. I'm just going to follow the lines that are already printed on my 3-hole punched paper. Lithium has 3 electrons. I fill the lowest orbital first, and I keep going up until I've used up all my electrons. That's my energy level diagram for lithium.
Also, you don't have to like draw
No circles, no squares.
It's basically like the house diagram, just like the
Yep.
house.
So basically what's going to happen is you're going to have labels,
Well, that's the house, okay.
and it's going to go up. You're not going to go down. If you have to get to your roof, you put the ladder on the ground, you climb up the ladder. You don't jump up. Okay? So we go up from the ground.
And then you fall and you go back down.
Yeah, no.